For decades, mind control and telepathy have played a prominent role in pop culture, often portrayed in movies as a way for an antagonist to take control of their unknowing peers, or used by protagonists to get out of a sticky situation.
You don't need to see his identification.
The technology and magic depicted for these processes has always seemed bound to the realm of science fiction. However, brain-to-brain interfacing could bring this type of technology to the world during our lifetime.
A brain-to-brain interface is a direct pathway between brains that can be used for communication. Making use of brain-computer interfaces, this process involves detecting EEG signals from one brain and then using these signals to determine how a second brain should be stimulated. This could potentially be used to either convey information to the second participant or to directly control their movement.
In 2013, this technology was shown to allow rats to communicate with each other about what action should be performed in order to receive a reward. Later that same year, the potential for this technology to be used to directly control movement in humans was demonstrated at the University of Washington. In the study, it was shown that one participant could control subtle hand movements of a second participant by activating brain stimulation through their thoughts. Although the success of these studies was somewhat varied, and the idea of telepathy and mind control are still science fiction for now, these studies have demonstrated that this type of technology could one day be possible, and it is important to understand the risks and benefits of the technology before it becomes widespread.
If research into this area continues to a point where a person's movement can be controlled more precisely, the results could greatly benefit people suffering from a number of neurological conditions. For example, this technology could be used to reteach stroke patients how to walk by allowing a therapist to interface with a patient's brain and helping them go through walking movements.
Evidently, there are several ethical concerns associated with this. Giving a therapist control of a patient's movement in this way makes the patient extremely vulnerable and has the potential to completely compromise the person's autonomy. A huge effort would need to be made in order to ensure that a patient understands all the risks and benefits of this type of treatment before consenting to the procedure.
Obtaining this kind of consent from certain vulnerable populations can be difficult in general, but there's an added level of complexity to this consent in situations where a person's actions are being controlled. It can become difficult to determine how a patient is able to maintain consent. Once a person's actions are being controlled, is their continued consent truly their own, or can it be influenced by the brain interface?
Data security and privacy are two other concerns that must be considered if this technology is to be used in a healthcare setting. An additional ethical concern with brain-to-brain interfaces is the argument that the development of this technology for medical purposes could be a slippery slope that could lead to this technology being used for other malicious purposes. There is a potential this technology could be used to control armies to follow orders exactly, as well as to influence entire populations to think in a certain way. Each of these situations greatly undermines the autonomy of a population and the rights and freedoms they have to make their own decisions.
Even if this technology is used for applications that are well-intentioned, it could still lead to some other ethical issues. For example, it is possible that this technology could be applied to make the process of learning more efficient, by allowing instructors to teach lessons through brain interfacing. While this could reduce stress and speed up the amount of time that it takes for a student to learn material, it could also make some students more susceptible to the biases of their teachers. It could also create a huge divide between people who can afford this technology and people who cannot. Due to the veil of ignorance, it isn't right for people to continue to perpetuate this type of advantage to people who are born wealthy and continue to contribute to the inequality between people of different economic statuses.
Although the majority of these ethical discussions can make this technology seem scary and daunting, it is important to weigh these risks with the benefits that could be achieved. As frightening as the dangers may be, it could be argued that it would be unethical to prevent people from accessing the rehabilitation benefits this technology has to offer, simply due to a potential for misuse.
Additionally, it is important to realize that completely stopping the development of this technology would be very difficult. Already, aspects of this technology are being used for other applications, such as deep brain stimulation for Parkinson's disease patients and brain-computer interfaces for people with paralysis. It is only a matter of time before these types of technologies become more developed and are able to come together to create a more effective brain-to-brain interfacing system.
As these developments continue, it's important to put regulations in place in order to minimize the risks associated with using a technology that raises so many ethical concerns. Keeping the PAO code in mind, engineers developing these devices should remain cognizant of public well-being. This could mean designing fail-safe systems that eliminate undesirable side effects of failure, prioritizing personal security, or analyzing the product lifecycle during the early stages of design. Furthermore, the correct use of technology begins with education, and therefore, emphasis should be placed on educating healthcare practitioners and patients about the benefits and potential risks of using brain-to-brain interfaces.
Above all else, an emphasis should be placed on ensuring public safety and well-being as these devices are developed.